Hello everyone. I hope the sound is okay. The first question is that I need someone in the YouTube chat, please, from the guys who are watching, that I get a thumbs up or something about the sound. So, Crazy Horse, just a short information about the sound, please. And if the sound is okay, then I would say let's start it. Our our May meetup today with Parity. It's a pleasure. We have talked just shortly how we do it today. The agenda is covered like we have it on the meetup.com platform. And this means we will straight start with some news. If anyone in the YouTube chat wants to have a more private communication, just check out our Slack channel. Or maybe if someone else is there who has additional material, this is the place to edit. And yeah, then the next slide is that we have an organization team of 6 people. It's the usual group. So Joshi, our talk presentation, our expert today, is kind of an acquiring from Ralf. And I hope some of the other Orga team guys will maybe join later. So yeah, let's use just 20 minutes on some news. And after that, we straight come to the insights into the Polkadot and Substrate Framework, which also includes some live demo. And I think it's about setting up some nodes. The link for the introduction and what has to be done is in the YouTube chat. So it would be really nice if the YouTube chats can check out the link already, because it's kind of a pre-preparation. So use your time well and enjoy meanwhile the news. So let's start with the first slide. I usually, or since the last meetup, I do a little bit of Bitcoin first, because Bitcoin has the biggest market capitalization. There are on the left side some funny news, like we have this kind of bunny Bitcoins, which are just bunny pictures and some hashtags. So enjoy a little bit of funny bunny pictures. But then there are some kind of more serious informations. For example, that MakerDAO has some new Maker DeFi stuff in the protocol. That's like on Twitter, you can find it on 1EX. And of course, I placed another more jokey Twitter post from Satoshi Germany news about, I don't know if it's serious or funny, mentioned Reddit post about Bitcoin versus Ripple. And nevertheless, I have just put some whale trade news from BitMEX, that we have some very big short and long positions. I mean, I would say every one of you guys noticed BTC is over 9,000. So I saved the meme over 9,000 and just put some Twitter posts from the whale trades. The second slide is a little bit more serious news about Huobi, which is not only a mobile wallet or a wallet for crypto coins or for cryptocurrencies, it's also an exchange like UOB Global. And I just put the news because they recently supported SegWit, and this means you can have now lower fees and kind of batching transactions. So I would say it's good news. Another thing is that their wallet has staking mechanisms. So it's also for the people who are interested in the DeFi products and passive income. It's for sure interesting. There's a QR code on the slide. So if anyone wants to read more in the Medium post, which I just cut out down in the slide, there is your link. I also want to say that Huobi is kind of minor in the volume, and I just put from CoinMarketCap some volumes just for you guys to give you some recent update. And I think the next news are from Ralf. So Ralf.
Yeah. Yeah. Hello. You can
Ralf.
Yeah, now I can hear you. And can you switch the screen?
The screen is switched. We have a little bit of time delay, so no worries.
Yeah, okay. Yeah, it's from today. Justin Sun, the CEO of Tron, has released a new coin. It was sold out after 5 minutes. Is there anybody on the chat who has sold some of these coins or has got the chance in the first 5 minutes? I don't know everybody or anybody who has who was a lucky person, and I don't know on which point means on coin market cap it is actually placed. But is there anybody who knows this?
No answer so far.
Okay, then we go to the next slide.
Yeah.
We have some time delay.
Yeah, it's just some milliseconds between the slides. So it's the delay between our Zoom and YouTube live stream. Right, no worries. It will come in a few seconds. So yeah, there it is.
Yeah, and this is also interesting. The question is, are these preparations of a financial Armageddon, or in other words, are these things signs of the restart of new money after the inevitable financial crisis after Corona? What happens? The big companies, JP Morgan, IBM, Microsoft, and Amazon, it seems that they're buying Ethereum and big amounts of Ethereum. And maybe if the money market goes down, or that what we say, what is money, it can be possible that we have a restart only with cryptos. Or the cryptos will increasing in the course, maybe. From my perspective, we will have a restart until the next 12 months regarding money. Okay. And the next?
Yeah.
I think we will inform you all from some local Saxony blockchain things. And the first one is that University Mittweida. This is not a university. This is we have a foundation project. We call it Blockchain Showcase Region Mittweida, and the next 3 big projects should be confirmed by the advisory board. And one project has the name Echt. And here we will have a solution, or there will be developed a solution for digital documents in Germany. And so documents that cannot be manipulated. And in this project, I think they will develop a prototype, and maybe the second one project is a blockchain-based social platform. It's a social service platform where citizens, or maybe some in German Vereine or companies, can administrate service orders. And in safety, the third one, in safety, industrial safety chain, here will be digital identities connected with videos. And so the name is in safety chain, so that video files will be protected uh, for be, for manipulation reasons. And the next is also based, the next slide is also based in Mittweida. The university Mittweida is hiring 4 people in preparation for an hopefully a big new showcase region program or project for digital identities. And they are hiring 4 engineers and oh, yeah, it's not on the screen.
I removed the slide, Ralf, I
And
removed the slide, so no worries. But the Mittweida guys, they are hiring. You can find the post on LinkedIn. It's not in the presentation anymore because I checked the link and it was not working. But if you're interested in the 4 open positions for engineers in the blockchain space, you can check out the BCCM Mittweida in Google, and then you will find the links to the positions which Ralf is describing. So
yeah, okay. And then I think we will finish our introduction in the news of the last 4 weeks. The question is to the people in the chat, do you know some news or important things? What happens in the blockchain area in the last 4 weeks? Then write it down.
yeah, exactly. That's a good call. So anyone, like we have some people in the chat, you can post the questions and we will also collect them. So we have, after the presentation of Joshi, a kind of Q&A and networking. Meanwhile, in this time during the presentation, I also check Slack. So, or you can send me emails, I guess, through YouTube if you want really PGP encrypted emails, also fine. Right now, Ralf, we don't have additional questions. And I also asked in German about the ticker of the new TRX coin. And
Okay.
I can also look it up during the presentation. So I think
Yeah.
there is a little bit time to introduce Yoshi and maybe also tell the community how the occasion happened that Yoshi is willing to do a presentation in our local meetup. So maybe it's the question to Yoshi and you, Ralf.
Yeah, what happens? We are looking for a long time that we get somebody from Parity to present Polkadot or since 1 year, but not more so actually, but what we want to hear now is, or hopefully, it's an introduction into Substrate. This is a newest product, and I'm very happy that Yoshi will be take part in an online meeting. It's much more easier before you come from Berlin. I think you're located in Berlin to Dresden and online meetup. Yeah, and I'm very happy to have you here, Yoshi. And I think you should, I will give over to you. You should introduce yourself and then you can start your Substrate presentation.
Yeah, sounds good. Thanks. Ralf, I didn't know that you were trying to get someone from Parity for so long. I've worked at Parity almost a year. I would have been happy to present it. So I'm glad that it worked out now and we have the chance.
Okay.
Yeah, so I mean, I met you guys through our, like, one of our events coordinators, and I guess, yeah, she was the contact point. But I love doing workshops and presentations and stuff like that. So this is like, you know, right up my alley, and I really like doing them in person as well. Obviously that hasn't happened very much lately, but this is like a totally cool way to do it as well. And it worked out great for me because, yeah, Parity is located in Berlin and most of our companies there, but we also have a decent number of remote workers. And so I'm actually located in the United States right now. So, you know, thanks to the virtual meeting, I'm able to be here with all of you guys. So I'm really happy about that. I doubt that I would have flown over, been flown over for the meetup. So I'm glad it worked out. So yeah, so let's see. You were talking about Polkadot. I think that's probably like the most high profile thing that we're building at Parity, and people are really looking forward to the launch. And we have this other canary network called Kusama, which is like a similar network to Polkadot. And what I'm going to talk about today is actually another product called Substrate, and it has a very close relationship with Polkadot. And I guess I'll talk about that as I start the presentations, and I have a couple slides about that. So I'd be happy to just dive right in. Is it time? Should I share my screen?
Yeah.
Okay, great. So can you guys see my slides?
Yes.
Okay, cool.
Yeah, I think it's fine. So let's kick it off.
Awesome. Yeah, great. Thanks a lot. Okay, so this is going to be like a combination presentation and then also workshop. And so the more people that can participate and follow along, the better. I want to encourage you to try to do it. And I've done meetups like this before, and in the past there was a lot of overhead. You had to like have a Rust tool chain installed if you wanted to fully participate. And for this one, it's the first one where I'm gonna try Docker. It's probably something I should have done a long time ago, but it's one of those, probably everybody has tools where you're like, yeah, I should know that, and you just haven't. So I just recently started learning Docker, and so I hope it'll help with that. So if you do want to follow along, or even think you might want to follow along, it'll be really helpful to have these slides in front of you, because obviously I'm sharing my screen, but there's also going to be some links in here. And so if you have the slides in front of you, then you can click on the links. And so this is how you get my slides: parity.link/sax-coin. And that's the sort of the name of the token that I invented that we're going to launch together today, or that I actually launched 10 minutes before I got here, and we're going to work with today together. So there it is. It's short enough. You should be able to just copy it down: parity.link/sax-coin. So I'll tell you guys just a little bit about myself. I told you I live in the States, and I really like working for a European company. This is my first time doing it, and it's been a real privilege. I used to be a physicist. That's how I was trained. I got my degrees in physics. After that, I was a high school teacher for a while, and I started as a physics teacher and branched into being a computer science teacher, which I loved, and then continued with computer science for a while. And in 2013, I first heard of Bitcoin, and read a lot about it, learned a lot, and then kind of lost track of it for a year or two. And sometime around 2015, then I started getting really into blockchain again. Ethereum was out by then, and I started leading like research groups at the school where I was teaching, and eventually it got to the point where blockchain was taking up enough of my mind space that I was struggling to, devote enough time to like the classes I was teaching, and so decided it was time for a career change. And so that's when I should say like beginning of 2018 is when I entered the blockchain space full time. So I've been with Parity for about a year now, and I work on Substrate. And I know I haven't told you what Substrate is yet, but I will on the next slide, so don't worry. And two particular products that I work on with Substrate are the Substrate recipes and the Substrate seminar. And so if you're a blockchain developer, or you're a person who likes blockchain and thinks you might want to try your hand at being a blockchain developer, or just learn a little bit about it and tinker even as a hobbyist, these are two resources that I'm proud of and working hard on that I think might be able to help. So I'll give you more info about how you can join and everything, but the central point, the landing point for all of this stuff is the website substrate.io, which I guess maybe I'll just show you since I'm sharing my screen. So like we don't have to click through a website together, but this is the jumping off point, and then there's links. This is my seminar that I talked about. If you like what we do today, you can join us every Tuesday at 1400 UTC. So for me here on this side of the pond, that's 10 a.m. And I think for you guys in Germany there, at least in Berlin, that's 4 p.m. I assume you guys are the same time zone as Berlin. Okay, but let's stay focused. So yeah, anyway, I love meetups. I said that already, and I really like interactivity. Like I said, I was a teacher, so if you have any questions or comments, please do speak up. I think the way we're doing that today is through the YouTube chat, and then Arno and Ralph will relay questions and comments to me as well. Yeah, right. So let's get right to it. What is Substrate? And sort of like the implicit question with that is, how is it related to Polkadot? And then just to help everybody recognize the branding, this is the Substrate logo over here. I think you have probably seen the other one that has the similar like lines, and it's like an equal sign. That's Parity as a company. This one is Substrate. So Substrate is an open source, modular, and extensible framework for building blockchains. So it's not a blockchain. It's not analogous to Bitcoin or Ethereum or Tron or Polkadot. Those are all individual blockchains. Rather, Substrate is a toolkit, a library or framework of Rust code that helps you build your blockchain. And it includes all of these pieces that every blockchain needs. So a blockchain is a huge engineering feat in terms of like all the pieces you have to put together to make it work. You need a database for storing all the blocks, and it's not just a matter of storing the blocks themselves, it's a matter of remembering their parentage and which ones are in the canon chain and which ones got forked off and which ones are close enough to the tip that we're not really sure if they're going to be canon yet. And then there's the networking layer, and in our case this is handled by libp2p, but libp2p is a whole enterprise grade software product of itself. And then there's a whole bunch of other stuff, transaction queue, consensus, the runtime logic. What is your chain actually going to do? And the point is that each one of these pieces is big, and to build them properly, you need a whole team devoted to your project. Now, some projects are fortunate enough to have that situation, and Polkadot has the power. If you say, I used to like this chain, but now the governance has turned into a problem and I'd like to fork off and do it myself, you now have the power of that. And we think that fits in really good with the blockchain space sort of mentality of self-sovereignty and decentralization and not needing to ask permission to do anything. Being able to recruit the talent to build all of these pieces yourself is sort of like a gate that keeps people from launching their own chain. And so with Substrate, we're trying to tear down those barriers and say, if you want to launch a blockchain, you can do it. Yeah, right. So obviously not every blockchain wants to be exactly the same. There's many common pieces that you will want to just use an off-the-shelf version of, but there's also things that will make your chain special. And in particular, for most chains, that'll be the runtime, and we'll talk about what that means in a second. But as the pink text says here, if you want to do something special with a particular part of our chain, you're welcome to use our database layer as it is. Most people do. Same with the networking and the transaction queuing. You can use those as they are, or you can extend them. You can add your own logic, or if what you want to do isn't even similar, this is nice and modular. You can just throw out our database layer and plug in another one. Now, in practice, the parts of the node where people are probably going to want to extend or replace are going to be these last two, either the consensus engine or the runtime logic. Okay, yeah, so speaking of all those parts of the node, let's just go ahead and take a look at this architecture diagram here. It kind of looks like a spaceship. And so I guess let me go in order here. The entire diagram represents a single substrate node. So if you picture a blockchain network with lots of nodes, each one of the nodes has every one of these parts. And the little pink blobs sticking out the bottom, these are ways that the node can interact with sort of like the external world or things that are outside of the diagram. So libp2p, that is our peer-to-peer networking layer. This is how our node communicates with other nodes on the network. So if you think about gossiping transactions or syncing blocks or sharing the blocks that your own node authors, that's what libp2p does here. And then JSON RPC is the way that a node communicates with like the end users, the people who want to participate in this blockchain. So you can think of submitting transactions, checking your token balance, or calling smart contracts. Those kinds of interactions between like users and nodes or like front ends and nodes, those happen over the JSON RPC here. And then all of these other organelles, these are things that are sort of inside of the node. And so there's a few that I just listed by name: block storage and transaction pool. And those are all interesting in their own right, but they're not the pieces we're going to focus on today with our demo. So today we're actually going to focus on these two pieces that I've shown sort of bigger, and one is consensus and one is the runtime. And so I haven't really defined runtime yet, but I will now. So the runtime is the application logic that makes your chain unique, or that makes your chain your chain. And I think the best way to really elucidate that idea is to just give a few examples of what the runtime is. So in Bitcoin, the runtime is a token ledger. It is the set of all the UTXOs, as they call it, or all the tokens that exist in the network, and the rules that are in the runtime say things like, you can spend tokens that you own, but you can't spend other people's tokens, and you can't spend more tokens than you own, and things like that. So when Ethereum came along, well, maybe even before that, you know, we had all these altcoins. Like, I think the most famous one probably is Litecoin from that era. And Litecoin's runtime is pretty much identical to Bitcoin's. You know, it's a token, spend your own, not others. Then Ethereum comes along, and Ethereum really generalizes this idea of a runtime. And it showed us that we can use a blockchain for a lot more stuff than just plain old money, which is really cool. So the runtime of Ethereum is like the EVM, or the Ethereum virtual machine. It's a whole smart contracting language in and of itself. And so think of your favorite blockchain, and you'll think of, you know, what the runtime is. Like, what thing does it help the users coordinate on? So another project that I worked on briefly was called Rchain, and their runtime was another smart contracting language, but it was a different computation model than Ethereum's. So anything like that can be put in the runtime. Or if you think of some of these like use cases that people talk about in the sort of traditional political system, you might think of like a voting application. And so then the runtime would be citizens of, you know, whatever state is using this application are allowed to vote. Each citizen can vote once per election. They can't vote twice. They can't vote for, you know, cast other people's votes, and non-citizens can't vote, and all that stuff. So the runtime basically answers the question, like, what story are we trying to tell with this blockchain? What are we trying to coordinate on? And so, as I said before, this is where most people will do their hacking. If you have a cool dApp idea and you want to build it on a blockchain made out of, you know, built on Substrate, you're probably going to hack in the runtime. And then another piece that people like to sort of plug or do their own thing in, you know, write their own component, is consensus. And consensus answers the question, okay, we have some runtime. How do we know what version of the story is real? So think about forks in your blockchain. How do we know which one of the forks is real? How do we know when something that happened on chain has become finalized? And I'll talk more about each of these shortly. I don't need to do it all right now. So so here's a cool thing that Substrate does that I haven't seen in other blockchain frameworks or in other even individual blockchains. So we write the whole thing in Rust. You know, that's cool for its own right, but it's not like totally unique. And we build it down to a native binary. But this runtime part up at the top, we do something special here. The runtime's still written in most cases in Rust. In theory, it can be written in other languages too, but in practice, they're all Rust right now. And then we build it not only down to a regular native binary, like a program you can run on your computer, we actually also build it down into WebAssembly. And what we do with that WebAssembly is we actually include it in the blockchain itself. And the reason that we do that is because it allows this feature, which we'll look at in detail later, it allows this feature that we call forkless runtime upgrades. And let me just give you a little bit of motivation for why you might want to do something like this. So in your favorite blockchain, you've probably experienced a situation where there's a bug discovered in the node. Sometimes they're serious. There was a one in Bitcoin back in 2010, before I was even aware of Bitcoin's existence, that I'll tell you about later, where people were, or not people, but one particular person minted millions of tokens. And that's obviously a really bad one. Other times they're not quite as bad. You know, you've probably heard people talk about like mispriced opcodes in Ethereum, and I mean, those can be bad too, but they're not quite as bad as like minting arbitrary Bitcoins. But the point is, as with any software, it's incredibly difficult to get everything totally perfect on the very first try. Like anybody's a software developer out there, you know that you debug and debug and debug and debug, and then it's finally working, and then you realize you have more debugging to do. So with a runtime upgrade, what we do is we say, when we discover one of these, you know, a bug that we need to fix, or if we even discover like a feature that we want to add. I think in the Ethereum network, they talk about like adding more pre-compiled contracts or like ability to use other hashing algorithms, you know, and there's usually drama about what goes in and stuff. So what we do here is we allow those things to be added without necessarily causing a hard fork. So if everybody agrees that we need to change the node logic a little bit, like they did when the Bitcoin overflow bug was discovered, then you can make this particular kind of transaction that replaces the old runtime with a new runtime. Now, in theory, it can be anything. It can be a totally different, you know, you can change Ethereum into a Bitcoin-like chain or something. In practice, it's going to be used for bug fixes and feature additions and things like that. And by including this as a transaction, we submit the compiled runtime onto the chain, and then every node automatically starts running the new logic from the chain. And we don't have this unfortunate situation where the network forks and anyone who forgot to update their node, you know, forks off and is left behind and then has to update later and do a big reorg and things like that. Now, there's a whole bunch of interesting things that come with this setup that we have here, like the question of, well, what happens if I didn't want to upgrade? What happens if I wanted to do it the other way? And the short answer is you can still do that, and you can still fork off anytime you want to, and we'll talk about that in detail later. But when you don't want to fork, or when there's not a contentious upgrade, then we don't have to deal with all those forks and coordination. Yeah. So we'll get to all that in due course, but for now I wanted to just point out there's all these parts of the substrate node. A few we'll focus on today is the runtime and the consensus, and depending on where your interests are as a developer, then you may be able to also focus on some of these other parts.
Yeah, Yoshi, can you hear me?
Arno, I see you talking, but you're muted.
Wait, how do I unmute? Yoshi, I just want to ask something here. Maybe it's an easy question because I'm not so much the blockchain developer, but can you tell me if the JSON RPC calls, the remote procedure call, I guess, is it like on which port? Which port do I need to open, for example, in my firewall to make it happen?
Yeah, sure, exactly. So it's totally customizable, and you know, if with your chain you can make it any port you want, but for Substrate by default, and I think most chains keep the default, the JSON RPC is port 99. Oh, actually, yeah, so there's two ways you can do it. Yeah. The regular old HTTP one is port 9933.
Yeah.
And then there's also a WebSocket port which accepts those requests on ports 9944.
Yeah. Okay.
Arno, can you write it down, the port numbers and in the chat?
I can do, yeah. Or so I got it's, yeah. I will write down the ports. And like the lib P2P binary, I guess, doesn't need any additional ports, right? Or is it like it also?
It does. Yeah, it does. This one also has a port of its own, and by default it's 30333. I don't know where the best place for me to write those is. I could add them to my slides.
Yeah. Do we have some kind of yeah? Okay, like this.
Here we go. This is the beauty of doing it this way.
So we improved your slides. So yeah.
Yeah, that's right. Nice. 9933 or 9944. Cool. Okay. Just out of curiosity, I wonder why you're asking about that.
Yeah, you know, as a German, we have strict policies when it comes to data security, and that's why I'm just curious about the ports. I mean, for us, it's not even easy to get the Windows RDP working, so that's why I have to ask, because realistically, if I'm in an enterprise environment, I want to have use of all these nodes, and they can only be useful for me if I somehow tune the ports or redirect them or know them at least. So that's why I was just asking.
I see. Yeah, that makes a lot of sense. So I've written the defaults in here, and then, like as I said, it's as easy as a command line flag to change the port if you need to or want to.
Yeah. Okay. So that was my question. Thanks.
Thanks. So, okay, yeah, so I guess I'll start by zooming in on the consensus piece here. So there's really two pieces to consensus, and back in the Bitcoin days, this was not really clear at all. And, you know, as we've done blockchain research over the past decade or a little over at this point, then we've realized that we can sort of split consensus into two pieces. And the first piece is called authoring, at least in Substrate terms, it's called authoring, and it answers the question of who gets to create the next block and when do they get to create the next block. And there's a whole bunch of different ways that you can answer that question. So probably the most familiar and classic answer is Bitcoin's, which is the proof of work algorithm. And proof of work says anytime you solve one of these math puzzles, anytime you sort of mine a block successfully, then you get to go ahead and author the next block on the chain. And so it's probabilistic, and the more mining power you have, the more likely you are to be able to author the next block. And it works, really good with a couple negative consequences, like just wasted energy. I guess that's like really the biggest one. But it also has a lot of nice properties, which is that it's, totally permissionless. Anyone can join a network and just start mining anytime they feel like. And then there's some others too. These next two, Aura and Babe, are of the proof of authority variety. Aura is a really simple one where you choose your authorities and then you just take turns, authoring. So Alice goes, then Bob, then Charlie, then Alice, then Bob, then Charlie. Babe is similar. You choose your authorities and then you use this like pseudo-random technique to describe who goes next. And Parity's done a lot of cool research around this in conjunction with the Web3 Foundation. And so, as a simple analogy, you can imagine like you've got your authorities here and then they just roll dice and the output of the dice says who gets to author the next block. And then either, any proof of authority algorithm can be sort of converted into a proof of stake algorithm. And the way you do that is you just say, okay, you have to lock up some tokens. You have to stake these tokens. And once you've staked the tokens, then you become one of the authorities. And so Substrate isolates that pattern really nicely. You can just take any proof of authority authoring mechanism, and then by using this simple thing that we call the staking palette, which I'll talk about soon, you transform it into a proof of stake algorithm. So I guess just to get like really practical, or maybe you don't know, I should tell you, Polkadot is built on Substrate. And in fact, that's where Substrate came from. When Parity started building Polkadot, it wasn't our first blockchain. Parity is famous for their Ethereum client, and we also had a Bitcoin client and a Zcash client. And so by the time Polkadot rolls along, then as a programmer, you start to realize like, hey, I've written this code before. I've written something very similar to this before. Maybe we can sort of abstract it out into like a little library or a piece of reusable code, and then use it in all these chains that need it. And once we started going down that rabbit hole, we realized, wow, there's actually a lot of really common pieces between all these chains. And so we abstracted them out into this reusable framework called Substrate. And so Babe is what Polkadot and Kusama are using for their authoring mechanism, and they're using it in proof of stake mode. And then there's this new sassafras one that we're talking about, which may eventually be part of Polkadot. And then there's also like manual seal is just a really simple authoring scheme, which basically says, a better name for it would be called like free-for-all mode, where anybody can author a block anytime they want. All they have to do to author is submit an RPC call. And that works really good in like educational settings or in settings where everybody in the network is trusted. It works terrible in like a public network because there's just way too many blocks coming in all the time and endless forks, and it doesn't really work there. But not everybody who builds a Substrate chain is building a public network, and so we offer manual seal too. And so the other piece of consensus is called Finality. And so it answers the question of not who gets to author the next block, but of all these blocks in your chain, when it's, potentially forked, how do you know which one is like the real one or the canon chain? And then it also answers the question of how do you know when this block is final, which is to say it will never be reverted, even if a longer chain comes along. And so this is also a newer piece of research. And so the one that Polkadot will use and that Parity and Web3 are really like doubling down or tripling down all their efforts on is this finality algorithm called Grandpa, which I think is really cool. And another one that you've probably heard of before that Ethereum is working on, which solves the same purpose but in a different way, is called Casper FFG, or Casper the Friendly Finality Gadget. So those are some options that you could use for finality. Another one is this cool thing that parachains will use. So in the Polkadot ecosystem, you have like the main Polkadot chain, And it has all of these other blockchains that are connected to it and can pass messages between each other and transfer dot tokens between each other. And each one of those parachains uses a finality gadget called, I don't know if they have a finalized name for it, but it's like Polkadot piggyback consensus or something like that. And so basically the way that works is you say, whenever I see that the Polkadot chain has mentioned one of my blocks and it got finalized there, then we also consider it finalized on our chain. And so it's not really like a pure finality mechanism on its own, but it's a way to pull your finality from another chain, like the Polkadot relay chain, for example.
Yoshi, I need to ask another question regarding this slide and the point of this cumulus. It sounds for me like it's somehow a side chains. Would you say we can say it's side chains, which are then?
Yeah, I think that's a good way to think of it for sure. Yeah.
So this means like I have a kind of a two-way peg, because normally if you have for sidechains two-way pegs, like you have to deposit or grant some token in the main chain, and then you do the sidechain transactions, and then there comes this finality on the main chain again, and the peg is released. Is this right?
Yeah, that's a really good way to think of it in terms of just the dot token itself. That's basically how it will work. So like if I want to transfer some dots from the main Polkadot chain over to one of these parachains is the term that we use, then basically what happens is the dot tokens get like locked up. I submit a transaction to the main Polkadot chain. They get sort of like locked up on the main chain. And then we have this protocol called XCMP, or cross-chain message passing. So a message gets sent to the parachain, a new wrapped token gets minted there, etc.
Okay.
Yeah.
Thank you.
And that's actually a really good question. And the one thing I'll sort of add on to that is that while passing the tokens back and forth is certainly a valuable use case that we do support, it's not only about the token. Really, you can think of each one of these parachains as having their own runtime entirely. So maybe one of these parachains works just like Ethereum, and maybe one of them works like some other smart contract. Like actually Edgeware is going to be a parachain that has a different smart contracting kind of like runtime.
I'm exactly on your side, and I want to ask a question which I was asked when I was talking about sidechains in Essen, which is a kind of a blockchain hotel conference last year. And they asked me, if we have in the sidechains some token or some just some token, do you think this sidechain token should be valued in price, for example, higher than the main dot tokens which are locked up in the main chain? What do you think?
Ooh, okay, that's interesting. So you're asking not about transferring dots to the sidechain, but like if the parachain has its own token as well, or something like that. Yeah. So I mean, I don't see any fundamental reason why that couldn't happen. I guess the interesting thing to think about is economic security. So the assumption you make in any blockchain is that the value, people will have more value, will gain more value by following the protocol properly than they will by trying to rip anyone off. So for example, like in a proof of stake protocol like Polkadot, people have to lock their tokens or stake their tokens. And so they can either follow the protocol and make some, reasonable income and return on the staked tokens, or they can try to cheat and like mint themselves some tokens. But in reality, what will happen then is that, they'll be slashed and they'll lose everything they staked. But it gets interesting when you start to think about these more valuable tokens that are on one of the parachains, where the security actually comes from the less valuable token that's on the main chain.
So it's a hard question. I don't know. I also didn't know how to answer it right. Maybe there's no right or wrong. But thanks for also getting your opinion on it.
I would have to think more about it. It seems dangerous is my first instinct. Yeah. But I guess my hope is that like, as that, it's unlikely that you would like suddenly snap your fingers and have the super valuable parachain. You would probably see it increasing. And then I would hope that somehow that would also drive up the value of the relay chain, or like the main chain token. I have not thought about that enough though. Don't take this as like advice on how to structure your own sidechain based. Yeah. Good question. Okay, cool. So I'm basically done with this slide, but the one last thing I'll mention is that you actually don't even have to choose any finality mechanism at all. The first blockchains famously did not choose any finality, and that's still the case on Bitcoin today. You know, however long the Bitcoin chain is, at any point it's possible. Now it's infinitesimally unlikely, but it's possible that a much longer secret chain will come out, and then everyone will have to reorganize over to that other chain. And so that's just what we call probabilistic finality. And then so for this chain that we're going to launch together today, I chose, you know, I think it's fun to make a Bitcoin-like chain. I remember back in 2013 or 14 when I was first getting into Bitcoin and seeing like, oh, somebody launched Litecoin. That's so cool. I wish I had the skills to like, you know, launch my own Bitcoin-like chain. And now with Substrate, we, you know, I do, and you or anyone with just a little bit of study also have that that option available to you. And so I thought for those reasons, it would be fun to launch a Bitcoin-like chain. So today we're going to use proof of work for authoring and no finality, just like Bitcoin does. Oh, I forgot I had text there. So yep, that's what we just talked about. Okay, right. So next part we're going to dig into is this this runtime logic, which is, you know, the part that I was saying makes your chain special. So this could be smart contracting platform or vehicle registration platform, or it could be a TCR, or it could be some like weird game like CryptoKitties, or you know, really anything that you can express in Rust code. Okay, right. So let's just zoom in on that, like that runtime bubble. So with Substrate, you have all of these different palettes available to you, and palettes is just you know, a word that we made up. It's like lingo to describe this architecture that I'm telling you about. And the idea is that you may have something very special and unique. Like if you're the creator of CryptoKitties, that's pretty special and unique, and you'll have to write that logic yourself. But it's likely that at least some, and in some cases all of your runtime is not that unique. And so you can grab some of these reusable palettes of logic and compose them together. So a really like a simple one, or it's not particularly like simple, but it's a simple to understand one, is the balances palette. So if you choose to use the balances palette in your runtime, that gives you a cryptocurrency inside your runtime. So you might, like if you're writing a TCR, for example, you'll have to write a lot of logic about like proposing new registry entries and challenging them and all of that stuff. But you'll also need a token, like that's the T in the TCR. It's a token curated registry. And so tokens are super common, like almost every blockchain has one. And so you can use our balances palette for that, for example. Another one is timestamp. Like this is an idea that's been around since Bitcoin, which is that every author includes in their block the time at which they authored them. And then there's just some simple validation rules. Like, you know, this block can't be years ahead of the previous block. It obviously can't claim to have come before the previous block. Let's see, here's the session one I talked about that, or that's slightly different, but here's the staking one I talked about that allows you to convert proof of authority into proof of stake. Here's democracy. That's one that is used in Polkadot that allows us to put some governance around how these runtime upgrades happen. And then one that we're using in our chain today is called pseudo, which is also a governance mechanism, but it's a very, very simple governance mechanism that is super useful for development, but probably not in public chains. And basically that says like, there's one particular key pair that can perform runtime upgrades. And so we'll see that today too. Anyone can write a palette here. You know, you could write a TCR palette that anyone could reuse. And like a one that we recently got actually, oh, in fact, it's in here. I did put it in the slides, is the EVM palette. So you can now write a Substrate chain that actually has the EVM as its runtime. You can make a chain that works just like Ethereum, but is built on Substrate. And so that's what the EVM palette would be, for example.
Yoshi, here also a question from the YouTube live chat.
Sure.
In the parachain feature, like the parachain which we discussed in the previous slide, is it included in the Substrate?
Oh, okay, that's a great question. So it can be, for sure. So the way that it works is that Polkadot is a blockchain built on Substrate, and it has a runtime just like the one we're looking at here. And one of the palettes that goes into the Polkadot runtime is called parachains. And if you include that palette, now your chain has the ability to have these parachains.
Okay, then
Yeah.
thanks for answering the YouTube chat.
Yeah, it's a really, really good question. It actually allows really cool things too. So imagine like, okay, you know, everybody starts when you describe Polkadot, you start by thinking about like, here's the relay chain in the middle, and then here's all these parachains around the outside. Well, now imagine one of these parachains also includes the parachain palette. And so it has like its own parachain. So it's like the sun in the middle with planets, and then planets can have their own moons, and it can be recursive. Like you can have layers and layers of parachains, or you can just build your own Polkadot like thing if you want to. So yeah, that's a very good question. Yeah, this is basically what I said. It's composed of palettes. So and I actually told you about this too, like whatever you choose to put in your runtime, whatever palettes you want in there, you know, maybe you have a cryptocurrency, maybe you have some smart contracts and some parachains. So you throw all those palettes into your runtime, you compile them down to WebAssembly or WASM, and then we put that WASM on the chain, and that is what allows us to do these like upgrades that I described earlier, and that we'll talk in more detail about after we get some hands-on experience. So yeah, great. So that's it. That's the overview of you know how Substrate works. Now let's actually launch this coin. And like here's basically a walkthrough of how we're going to do this. And it's possible that we're going to like run into hiccups and go back and try again or whatever. But this is what we're going to do. We're going to start with a super centralized chain where I'm sort of like in charge because I'm running the only node, and it'll be basically like a demo. And then once we have a little bit of hands-on experience using it, then we'll start to decentralize this chain and sort of make it belong to everybody. And then, you know, I don't know how much time we'll have, but if we have enough, we can even, you know, practice like governance around those runtime upgrades and stuff. So great. So here we go. We're going to start off very first with the like minimum viable infrastructure that one needs to sort of claim that they have a blockchain. And this is my like fancy architecture diagram. And so on the left side here, you know, you can see the Substrate logo, and this represents a single blockchain node that's running on the network. And then on the right side, this thing represents a user interface or some kind of user agent to work with the node. So in practice, I'm going to run this node on a VPS that, you know, Parity leases, I think, from like Google Cloud or something. And this is going to be an in-browser, like basically a web app that communicates with our node over that JSON RPC. The node won't communicate with any other nodes, at least initially, because there aren't any other nodes in the network. And so that means like this is every bit as centralized as Amazon or Facebook or anything like that. And the only thing that makes it blockchainy at this stage is that we're using like a blockchain data structure, but it's not really providing any of those promises like being permissionless or being decentralized or anything. But that's what we're going to work toward as we go through this presentation. So okay, yeah. So actually, let me just get this spun up before we go any further. So this is my cloud server. This is the VPS that I was telling you about, and what we're looking at here is the logs, like the output of this one single node. So maybe I'll just make it hold still for a second, and you can see like every once in a while you get one of these messages that says idle, which means like, you know, the chain is just, or the node is sitting there like doing its thing. And then it tells you how many peers. Well, it has none. That makes sense. And then it tells you what block we're on, like the best block that it knows of, or the tip of the longest chain is another way to say it, is like 1,170. And I actually started this like just before I got on this call. So in the last like almost hour at this point, you know, my one node has mined about 1,200 blocks, and then finalized 0. So, you know, that might seem like a bad thing, but it's actually what I expected. And I'll leave it as like a question to the field, like why is my chain here not finalizing any blocks? And if you have a hypothesis, you can just throw it in the chat, and then we'll, you know, see what kind of answers people come up with. Some other messages that you see are this one where it says it imported a block. In general, that means, you know, the node heard of a block from somewhere. Either it authored it itself or it came across the network. In this case, they're all self-authored because there's only one. But yeah, and like this one says that we authored a block ourselves. So I'll leave it at that. Like, we don't need to go super deep into these log messages. They're normal. And this looks like a healthy network, with the exception of it only has one node, and that's what we planned for now. So let me show you this piece next. This is the user interface. And actually, like, you guys can follow along on the next slide. There's this link called Start the UI that you can click on. And yeah, and that's it. So like, this is not like a super rigorous way of making sure you're on the right chain, but it's like a quick and dirty way. I just checked that it says like Sax coin mainnet, and we checked that we're on like 1200 and some blocks, and that, like, yeah, it tells you you're on the right chain. So yeah, right. So on this accounts tab, there's a couple of accounts here, and what I did was I went ahead and pre-funded these accounts. That means, like, in the Genesis block, or the very first block of the chain, I just gave a few of these things initial balances. And I did that just because, like, we're just practicing and learning here together, and it's a nice way to sort of get started. So anyone, basically, like, these accounts are well known and everybody knows the private keys to them, and they're just hard coded into the UI. So you shouldn't think of these tokens as being like your tokens or anything, even if you want to use one of these accounts, because like literally anyone can use them. Like, I'm going to rob Alice right now by having her send 1,000 tokens over to this other test account called Ferdy. And I click make transfer, and then I sign it, and I'm able to sign it because, like I said, the UI, okay, so well, yeah, I didn't get to rob Alice. So let's take a look here, and I'll maybe get to show you guys some Substrate debugging. So, I think let me just see if I know the problem real quick here. Yeah. Let me see if that's gonna fix it. If this fixes the problem, then I'll explain what I did. But let's check first before I. Not yet. Okay, so let's talk about it a little bit. The error message is could not, this part, could not convert parameter TX, stands for transaction between node and runtime. And then it says, oh yeah, no such variant in enum multi-signature. So okay, so let's talk a little bit about what that means, and then we'll try to dive a little deeper. So on this architecture diagram, the entire thing is the node, and in the error message, it's sort of referring to the node as like being all of the parts of the node except for the runtime. And so the issue that it's having is that, you know, I sent it some transaction, I created it, I signed it, it's just a bunch of binary data, it comes in over JSON RPC into the node, and then it tries to get passed into the runtime to be executed, and somehow the runtime wasn't able to understand the same data that the node gave it, which is a little bit of a bummer because I thought I had tried that right beforehand. So here's my next debugging step. I'm going to kill my node, and if any of you guys were connected to my node through that UI, you probably just saw your UI stop working. In fact, I can show that too. So like my UI looks like this now, you know, it's saying, hey, I can't connect to the node, and that's because I just killed it. And this is actually, like, I was going to do this later on in the talk and make it be kind of like a unfortunate, like, you know, surprise, like this is what happens when you have a centralized network, anyone can just kill it. But let me show you what I was going to do here. So this left terminal, this is the cloud server that I was saying that Parity has for me. And now this right terminal, this is just my own local system. So let's try this again here. So I'll run my node, Sax coin, and I'll purge the chain. That means just like throw away all the blockchain data just so that we're starting fresh. And then this time I'll run it and I'll say I'm a validator. That means I'm gonna, the phrasing is a little funny. You usually use the term validator for like proof of authority or proof of stake networks. And since Substrate was created sort of with Polkadot in mind, we took that lingo, but what it really means in this context is that I want my node to be a miner. I'm going to be authoring blocks here. So I specify the validator flag, and then like optionally, you know, you can give it just like a human readable name here or something. So like Joshy's local node, that part's not really critical. So now you get to see the beginning of it. Like, okay, this is good. Yeah, it tells me the name of my node. It tells me we're running Sax coin mainnet, all that stuff. this means I'm a minor. And then like we start to see all those normal messages that I showed before. And so, okay, yeah, so we're up and running again, and I'm on my local node. Okay, that all looks good and normal. Cool. And let's see if the transfer works this time. We'll just send some tokens to Bob. And we wait for a block to get mined. Okay, and that worked. So that's interesting. So now the question is, why didn't it work when it was on the mainnet? We'll have to see. So one thing you always have to do is like check your Genesis block, make sure you're on the network that you think that you're on. And one of the first log messages up here is this one. So like, you know, I started a brand new blockchain network, so it tells me about like the Genesis block, and I can see that its hash is like 8CE2, and that'll be enough just for now, just to see what we have. So okay, so I'm on the left tab, so I'm back on my cloud server. This is the one we were all using together. And so we'll run this thing again. I'll purge my chain. Yes, I really want to delete all 1,200 of those empty blocks. And then I'll try the same thing. Validator, name, Joshy's cloud node. I always give it a name when I'm running too, because otherwise it's too easy to get yourself kind of confused about which terminal you're looking at or anything, whatever. So this looks good, you know, healthy like it did before. We're on block 2, and like here you can see I show a different block number, and that's just because, well, you know, I'm connected to my local node. So on the settings tab here, then I can okay. Yeah, so on the settings tab, I can tell it what node I want to be connected to. And let me just give you a little insight into it, like how I tried to fix it before and what I saw now. So when we're using a network like this, we're passing data back and forth in binary format, and it's just the case, it just happens to be the case that like all we're sending is pure data. And so you have to know that the two things on either side of the arrow know how to speak the same data format. And the way that you tell the user interface what kind of data types the node is understanding is by putting them into this like sub tab called developer here. And so there's just a few that we need to have in here. Some of these are even extra. So like the one you saw me add when I was guessing was this one, which I think probably is correct and necessary. And now that I think more about it, I think I probably need these two as well. And like, that's a little beyond what we're going to go into detail in here, but let's just see if we get it fixed up, and then I'll just tell you everything you need to do. So, but while we're here, you know, I'm choosing like what node do I want to connect to? And like, here's just a bunch of examples of nodes that are in the real world built on Substrate. So like Kusama, you know, that's the famous Canary network that's a lot like Polkadot. Edgeware is a smart contracts one that I mentioned earlier, and etc. Like this is a Polkadot testnet, etc. So anyway, I'm going to tell it I want to connect to my own custom one here, and it was at WSS, so that's like a secure WebSocket, and it was at saxcoin.bootnodes.net/node. I'm pretty sure. So let me save and reload. That didn't seem to go. So let me just go back to that link then. Here it is, start your UI. Okay, there we go. We're back on the mainnet. We're at 34 blocks. That seems right. And then on this developer tab, yeah, I don't have all that stuff that I needed. So let me copy those data types. And okay, here are the other two that I think I needed. Save, refresh. Okay, so we're still connected, and here we go, fingers crossed. Let's see if we can make a transfer now. Yeah, nice, Arno. Okay, cool. So that went through. You can see it's in the block, and like you can see that Alice now has fewer coins, and you can see that Ferdy also now has fewer coins. So in order to let you guys all participate and follow along, let me just copy that all. And I'm gonna just do it in this like kind of not that sexy of a way, but I'm just gonna make a new slide. And I'm just going to paste it all right in here. Custom types for Saxcoin node. Okay, cool. There we go. So if anyone's following along, which I hope you are, you know, like we hit a little snag, no big deal. I'm sure Satoshi went through much worse than that. You now have the types that you need, and the way that you use them is you just you paste them into this settings, and then you paste them into developer, and that's it. So okay, yeah, awesome. So let's pick up where we left off. So we've seen this architecture. It works, you know, fine, but as we mentioned, it's not really very decentralized or anything like that. So what we want to do now is something a little more like this. This is like looking a little bit better because more people are sort of using this node, and there's a bigger, like, you know, community of users of Saxcoin. So that's healthy, but it's still not, the node itself is still only one. There's only a single user here. But that's okay. We'll solve that problem next. For now, what we want is more people to be users. And so you can go and here's another link, start the UI. And then the next thing that I hope that everybody will do, or that you're at least open to trying, is to create an account and share your address. So this share your address link just takes you to this. I don't know if anybody knows HackMD. It's just one of these, like, you know, websites where like we can collaboratively edit a doc. And you know what I'm hoping will happen is that you'll create an account and put your address in there. So let me just show you. So on the accounts tab, you know, we've got all of these like shared accounts. Like I was using Alice's earlier. I helped Ferdy steal some of her tokens. And so now I'm just gonna, just so you can, I used this add account button in the top right. And what's gonna happen now is that our browsers are each gonna generate keys for us. So like, instead of using Alice's, which everybody knows, now you're going to have your own private key, which is truly private. And so then once you own those tokens, those are truly your tokens. So, you know, it's straightforward. You put in any name you want. Oh, you're not supposed to share your mnemonic phrase. So like, I guess you guys can still steal my tokens since I am screen sharing, but, you know, and then enter any password you like. And then you can just click save. And, you know, if this were a real network, and honestly, the realness of this network is sort of up to us. You know, if we keep running our nodes after this, and maybe it'll be the next Bitcoin, you know, who knows, then you can save this backup file. I'm going to skip it for now, and I'll save it again later once we're listed on CoinMarketCap. But for now, it's in my browser storage still. And so you can see down here at the bottom, I have this new account called Joshi. And no one else has that. And no, you know, other than the fact that I was screen sharing, no one knows my private key, and no one can spend these tokens. So what I'll do now is I'll just send some from Alice to myself. And you know, let's see. That's a number I like. It's easy to type. So I signed that transaction as Alice because she's the one spending her tokens. And now you can see I have my own tokens here. So we'll just take a few minutes. I want to encourage everybody to go ahead and do that. Create an account, share your address over here. Oh yeah, so like if you want to share your address, I didn't tell you yet, this is the way you do it. Like you can click on these little identicons. You can click on any one of them, and I'll click on my own. And then it says, you know, address copied to clipboard. And so then, you know, I can just like paste my address in there. And so if I see someone else's address coming up in here, then I can send you some tokens. Or actually, you know, honestly, like you can take tokens from any one of these pre-funded accounts and send them to yourself. So yeah, so give it a try.
So wir haben jetzt noch, sorry Yoshi, we have also Johannes in the Zoom. He's also from the Orga team. Johannes, can you tell us, are you going to do it, or Ralf and me?
Hi Johannes, welcome.
Okay. No response.
Johannes, your microphone is muted.
Yeah.
So in the chat, no one is asking. Maybe we can just wait a little. It's no worries. I also will go through the links.
Cool. Yeah. And it's, you know, it's no big deal if people want to take their time or do it afterwards. That's okay. I can, you know, still demonstrate and everything. That'll be just fine.
What happens if the address is not yet like created? If I just take some hash and say this is my address, but it's not there, then you get an error to debug, or?
Oh, that's a good question. It doesn't, so yeah, so that is a good question. If you can give me any valid address in, like, you know, even honestly, like, okay, so let's say I create one like this, you know, I do add account and like, let's just, you know, I don't know, whoever this is, like Billy Bob. And we'll just give him some weak password and do the same steps that I just did. So like this thing is here now, but that was not an on-chain transaction. So like Billy Bob's account doesn't exist on the blockchain any more than it did before I created this account. Mm-hmm. It's only once I send some tokens, or, you know, maybe he calls a smart contract. This chain doesn't have smart contracts, but some do. Only once something like that happens that then, you know, this account sort of exists on the blockchain. So if you, I don't know exactly what the assumptions are or like what makes one of these addresses valid, but you can give me any like valid address, whether it exists on the chain or not, and I can send tokens to it, and then it will then it will exist. But you know, like let's just try. I'll just make up one that's like the right number of, well, not spaces, the right number of characters, and see what happens. I'm thinking probably there's some checksum in here.
Maybe we just have to use Yoshi's, but change the last 3 letters. For example,
that's a good idea.
PSC, and we make PSK, for example.
Yeah. And that's a great idea.
Then it would be like, if we don't have the passphrase, then we cannot access the coins, but we maybe see the balance on this address, right?
Yeah, exactly. If this is a valid address, I can send the tokens there. And then, yeah, and just like you said, no one knows the key to this one, so we can't then do anything else with them. But
so yeah, it's like burning. So we would include.
Exactly.
Yeah. So it's
like burning with this weird infinitesimal outside chance that at some point in the future, someone might accidentally discover the key. But yeah, it's like burning. Yeah, for sure. So yeah, let's just see. I think there's a checksum built in there so that, like, because what we did just now is really similar to like if I typoed this thing, and, you know, I wouldn't want you to send me tokens that were worth real money and accidentally typo it and, you know, like you said, burn them. So I think it's going to complain that that's not valid, but let's take a look.
Maybe he changed it to Yoshi again in the address field, or he took the typo.
It's possible it went in for sure. My balance went down. So either there's no checksum, or we just chose a valid one, or I accidentally switched it back to like my to like my Joshi account. So let's try this other totally bogus one. Oh yeah, it's going. I think this is where it's telling me that that's not a valid account.
So what did I do if my address book doesn't have these accounts? Like, I mean, the WebSocket, if there's any account which is, so no, actually it checks all the accounts which are on the node, right? Or in the network. So I would say.
I think what it's doing is it's checking the text that I paste in here and saying, is this a valid address? And when it discovers that it's not, then it's going to come back to one of these accounts that was in my address. In fact, here's what we can do. Here's how we can check it. So let me copy this Joshi one. We know that's valid because I generated it like the normal way. I didn't just make it up. And then let me come over to this other web browser, totally separate browser. Maybe that was it. And see if I can get connected here. No, not yet.
Or what about going over not the web front end? Like, if there is do we can send the JSON RPCs directly through a console? Like
you can, yeah, you can. I don't remember the format for how to do it, but let's see what happens here. So since I'm in a new browser, I don't have my Joshi account here anymore. It's like a separate address book. So let's see if Bob can. So now I'm pasting in this Joshi. Oh shoot! Let me copy it again. Got it. Okay. paste in my Joshi address. Yeah, okay, and so now, it doesn't know this thing's called Joshi or anything, but it recognizes that this is a valid address, and so it'll let me paste it in there.
Mm-hmm. But is it not dangerous, because then I can check for all the valid addresses this way? Like,
I tried to send too many tokens.
Yeah.
Yeah, so you mean like if you wanted to just send your tokens to some random address?
No, not only random, I can spam all of the addresses which I figure out they are valid. But
Yeah, you can do that for sure, but I think spam isn't quite the right word for two reasons. Because for one, you're giving them tokens, and for two, you're paying the transaction fees to make sure that everyone is like properly incentivized to execute those. Yeah, but yeah, you can definitely, I mean, airdrop would be like a better word, I think, where you're just sending out tokens to valid addresses.
Okay.
Yeah, cool. Yeah, good conversation there. So let's keep rolling. We did this. Yeah, so this is the part where I was gonna do that like evil thing, where there's 4 or 5 people that are connected, and then I like, I kill my node, and it's like, ha ha ha, this is what happens when you only have one node. Like, I can be so evil. So and yeah, so the next thing we want to do to make our node or our blockchain network like more resilient, more decentralized, meet more of these promises that blockchain originally offered, is to make it something like this. So what we're showing now is a bunch of different substrate nodes, in this case like Saxcoin nodes, and they're connected with these solid arrows. So that's our libp2p connections. And then the user interfaces can connect to any node in the network that they want to. Like, yeah, maybe this one's still connected to my node, but this one over here is connected to some different node. And then this beautiful thing happens, which is, maybe the owner of this node, maybe the owner of this node decides they want to like be evil and kill their node. No problem. The network still exists, and whatever user this was can just connect to a different node, and they still have their tokens, and everything is still working just great. So yeah, so let's just create one of those. So I'm gonna kill my local node, which is on its own sort of like private separate network over here, and I'm gonna purge its chain. Whoops. So it's starting fresh, and what I'm gonna do now is I'm gonna have this local node actually connect to the same blockchain network that my cloud server node is on. And so to do that, I just need to grab this information from my cloud node way back at the beginning. And it is specifically like this piece of information, the local node identity. So here's what I do. Here's my command. I'm going to start my node. I'm going to give it, validator again, just like I did before. I'm going to give it name Joshi local. I can't remember if that's what I called it before. And now I'm going to give it this additional flag, boot nodes. And I'm going to tell it like in libp2p world and everything that builds on libp2p, we call it a multi-adder. And so I think the format is like this, and it might take me a time or two to get this perfectly right, but I think this is how it works. I give it DNS4, and then I give it saxony.bootnodes.net, and then I give it TCP, and this is what you were asking about, Arno. I think it's part 30333. And then I give it this like P2P address, and that is the thing that I copied from right over here. So basically what I'm doing is I'm telling my local node like, hey, don't just start up your own chain and do your own thing. I want you to dial up to this particular node that I specified right here and synchronize whatever chain it has. And it will also synchronize, our local blocks, which happens to be none right now. And then we'll have one blockchain. So let's see what happens. And look at that. Right away, we're already up to like block, let me hold it still. We're up to block 300. And that's not because my local node mined 300 blocks that fast. First of all, that's way too fast. And second of all, we didn't see all of the like log messages for that. What really happened is it synchronized those blocks from the cloud server. And so now our network is starting to look a little bit more like this. It's, maybe a subset, like we have 2 substrate nodes in the network now. And so if anybody wants to follow along, you certainly can do that. I have this, like I said, I learned Docker in the last few days, or I am sort of a novice at Docker now. And so I published this Docker image that will run the node, and here's all the commands that you would need if you wanted to do it. And then I guess in the meantime, I'll just check out this this telemetry website here. And so what we see basically is there's two nodes in our network. We can see that they each have one peer. We can see that they're on basically the same block. And we can also see, like, occasionally when one of them authors a block, it takes the other one just a second to synchronize that block. And so as more and more nodes come into the network, then we'll get more and more lines on here. And this is, I'm not like running this app myself. This, you know, this is part of Polkadot.io, and Parity just hosts it for anyone who's working on Substrate to kind of have conveniently available. Maybe we can just look for a second at like a live network. So like here's Kusama, you know, you can see it has a ton of nodes, 400 and some. And in this case, they're not even all on exactly the same version. They don't have the same number of peers. This is like a real production blockchain network and what one should look like. Edgeware is another one like that, you know, slightly different versions of the node and etc. And then there's others on here that are just more testnet-y sort of things. Like here's one that just has a dozen nodes or so. And then like ours is small enough that it was pushed into this overflow thing here, and I always just find it with the search. So there's our node. Okay. So yeah, okay. So I guess now's a good time to talk governance. Or actually, are there other questions on the YouTube?
No, so far no more questions. Just a comment which you already answered about the address thing which we did. There was a comment that it checks for the right format, like the addresses have to have a specific format.
Yeah. Good. Yeah, I'm glad whoever figured that out. That's awesome. Okay, yeah, great. So I talked earlier about this like forkless upgrade thing that we've added, and so I want to talk a little bit more about that and how it works. And I guess I'll start by just doing a throwback to like the old way, and we'll talk about how hard fork upgrades work. And so this is a screenshot from the Bitcoin forum, and you can see when it's from, like summer 2010, so early in Bitcoin's existence. And someone just posts like, hey, it seems a block 74,000 and some has exploited a bug in the net. It causes an integer overflow. So for the non-dev people, an integer overflow is like in computers, integer, you can only remember numbers so big, you can only store numbers so big. Like, and if we're using a small, just imagine we're using a size of data that can only remember like 2-digit numbers. And then I ask the question like, okay, what's 90 plus 20? Well, the answer can't be 110 because we only can store 2 digits. So it overflows and wraps back around, and then the answer is 10. And so, you know, this is something like that you have to check when you're writing code in C. You know, maybe a little bit of a shameless shill here, like with Rust comes with a lot more protections to help people prevent errors like this, although it's not impossible. Anyway, so this bug existed in Bitcoin. Somebody noticed it, and they submitted a transaction where it created this many plus this many tokens. So I don't know quite how big that is, but it's a lot, and it's definitely more than the 21 million tokens that Bitcoin, you know, is supposed to max out at. And then they correctly observed, like, yeah, we need a fix as soon as possible. So what happened was, you know, someone who knew how to code, I think it was Gavin Andreessen actually that fixed this one, opened up the Bitcoin source code, fixed the C code, recompiled it, gave everybody a new copy of the binary, and they all upgraded their nodes. Or they didn't all upgrade, but many people upgraded, and eventually everyone upgraded. And the new nodes would not accept this transaction. So what that means is, here's our blockchain, you know, here's the old buggy logic in our chain. Like this, I guess this would be the block, like that third gray block would be the one that had the illegal transaction. And, you know, it at the time, it was only illegal in the sense that the humans who used the chain didn't want that to happen. It was perfectly legal in the sense that the Bitcoin source code said it was legal. And so that's why everybody kept building on this chain. So, okay, so Gavin fixes the problem and releases the new node. and everybody who runs the new node now rejects this block. And so we get this fork where the people who are running the old logic are still up here on the gray chain, and the people who are running the new logic, they're down here on the pink chain without the overflow. And so this is really unfortunate, because anyone who's using a node that's still running the gray logic has a different view of the world and a different view of what tokens exist than the people who are running the pink chain. And it's not just about those overflow tokens or that one transaction that created all the tokens. These blocks are also filled with hundreds of perfectly valid transactions that are going to be orphaned off just because of this one bad one. And so what we really want to do is enable a situation where we can fix bugs like this without causing this fork, and without having to post on the forum like, hey, everybody, please update your nodes as soon as possible, and try to do this coordination effort. Because when you have a properly decentralized network, coordinating that many people to update their nodes is a real pain. And then the bottom line is it's not going to happen cleanly once you have a big decentralized network. So this is the old way. This is hard fork upgrades. So this is what Parity has enabled with Substrate. It's called forkless upgrades, and it's enabled by the feature that I told you about earlier, which is that we take our runtime logic, we compile it to WASM, and then we store that WASM on the blockchain. So here's how it works. The old logic, the chain's chugging along just fine, and in this particular block, a transaction comes in. This is a transaction just like anything else, like a token transfer, or like a smart contract call, or like breeding your crypto kitties, like voting in an election, whatever your transactions are. This one is called a runtime upgrade transaction. And it submits the new WebAssembly blob into the blockchain. And every node who's syncing the blockchain, like a second ago, you saw my local node synchronize all the blocks from the cloud node. So every node in the network gets this block that contains the upgrade, and they see that there's an upgrade, and they start running the new code that's included in the block.
I have a question, Joshi.
Yeah, sure.
At what node, like if I have two nodes, at what node do I have to put it, and how is the consensus found about, we accept that one node wants to go with the runtime update?
Yeah, okay, so that's a very good question. You're getting at exactly the right things. So it doesn't have to go to any particular node. It, like every transaction, like a token transaction or anything, it can go to any node in the network. But the interesting part is the second part of your question, like, how do we agree that we actually want to do this? Because in the example I just gave, it was pretty uncontentious, like everybody wanted to fix it. But there's been a ton of contentious forks too, like, do we revert the DAO hackers work? That caused Ethereum Classic. Or like, do we increase the block size? That caused Bitcoin Cash. And so not every upgrade is gonna be like this.
So what's the answer now?
Yeah, good. Yeah. Good question. So the answer is your runtime, where the upgrade is processed. The runtime logic that accepts this transaction. That's where the checking happens. And there's multiple different ways you can answer it. So let me give you examples of ways to do it. The way that I have in Saxcoin is a dead simple one that you wouldn't use in the real world. And the way it works in Saxcoin is that any transaction that is signed by Alice's key, any runtime upgrade transaction that's signed by Alice's key is accepted and goes through, and anything that's signed by another key doesn't go through. But like in Polkadot, you obviously need something better than that. And so in Polkadot, they use this governance palette. And so what you do then is it's not a single transaction. Yeah, go ahead.
No, I'm just following your instruction. I am setting a flag on the nodes, right? Like instead of using one address or one private key to submit the runtime transaction, there is kind of a voting or whatever mechanism on a node to change a flag, and then the node will accept the runtime from anyone.
That's really that's super close. It's even more abstracted than that, because like thinking of it at the node level, that's how it would work in like a proof of work or proof of authority sort of network. What we're doing here is we're actually allowing the people who have an interest in the chain, which is to say the token holders, to cast votes on this thing. And if enough votes go through, if enough people who hold tokens say, we want this change, then at a later block, it gets included. So the flow is like, someone proposes a change, that truly can be anyone. Then the voting happens, and then either it goes through or it doesn't.
Mm-hmm. And then this means the runtime transaction change actually comes from a smart contract where the voting is happened then, or?
Yeah, that's right. It comes from we would use the term like on-chain logic instead of smart contract.
Yeah.
Just it's like a not a very important distinction at this level, but
Okay, good.
that's exactly right.
Then I got it. Yeah, perfect,
Cool.
resonance, and thanks for.
Yeah, it's really interesting. Like I think there's a lot of people who would agree and consent to be part of a network where they might not always get their way, but they got to participate in some kind of fair mechanism. Now, maybe you don't think democracy is fair, and that's fine. You're welcome to write any other kind of mechanism. And then, like, maybe I voted against this change, but the majority of my peers voted for it, and so it went through, and then fine. But you can also sort of imagine like that I was down to be part of this democracy. It sounded good. We did a couple upgrades. I voted for some of them and against others, and we all stayed together as a big happy family. But now there's like some really, really contentious one that's going in, and maybe it looks like it's going to pass, but I don't want it. Or maybe it looks like it's going to fail.
I think the important thing is also what you mentioned is that if it comes to the vote, that at the later time, at the later block, the change will happen. Meaning, if I have any position which is not fine with going to the new logic, I just sell all my tokens or I change to a different network or whatever.
Bingo.
So I think it's fairly to say that it is democratic because you can somehow opt out of the network if you are not agreeing on it. So I think it's fair. It's fine. Yeah.
Yeah. Right. Yeah. So you have like all these different options. You can be like, it's going to go and I like it. Obviously, then you stay with the network. You can be like, it's going to go and I don't really like it, but I'm not that against it. And I see other people like it, so I'll still stay with the network. Or you can say like, it's going to go through and I hate it. And I'm selling every one of my dots and using the money to buy, like whatever other token I like better. And like, I'll be a citizen of that chain in the future or something like that. Yeah. Actually, I should have had this chain, this slide on the screen when we were talking about that, because this is like, pseudo is the simple one that says, if Alice signs it, it goes. Democracy is the one I was talking about that Polkadot will use. And then you can also like write your own logic entirely. Like maybe it's something similar to pseudo, but instead of just being Alice, it's like, a quorum of 10 trusted keys. And if any 5 of them sign it, like, anything you can express in Rust code can be used as the logic to determine whether the runtime upgrade goes. Yeah. I don't think we're going to have enough time to go through this experiment right now. So maybe this is actually a good place to just wrap it and start to take questions. Does that seem like the right timing? Yeah, cool. Okay.
Yeah. Okay. I will start. The first question what I have is there a roadmap for Substrate available, a timely and a functional roadmap?
There's not a single clear document that we call like the roadmap, but I would say the best place to follow along is this website, substrate.io, and there's like a newsletter that you can subscribe to. But I can also speak to this a little bit. Like the Polkadot launch is coming up sometime soon. Obviously, I don't know when, and couldn't say even if I did. But we're very near to Substrate 2.0. So I think we're on 2.0 Alpha 7 right now. So I'd expect in the next month or so we're going to tag Substrate 2.0. But even today, you're ready to build real world live blockchains on Substrate.
Yeah, but I have received a release date in November. It is in 3 days, I think yesterday or 2 days before, 3 days in November, where there is a Substrate maybe webinar course, and this is also an announcement that on this date will Substrate released. Is it right?
I'm not sure. It doesn't sound familiar to me. Yeah.
Okay.
Yeah, I don't think so. Yeah. My personal hope was that Substrate 2.0 would come out before the Polkadot mainnet launch. I don't know if that's going to happen or not. I thought it made a lot of sense, but who knows? Okay.
Yeah. And the second question, what I have, it was very fast. If there are some people which are not so familiar with the things what you have done and the the detailed commands and so on. Is there an actual documentation where we can read it and try to follow?
Yeah, totally.
With Docker.
Oh, what was that last part?
With Docker, not the
for Saxcoin. Yeah. So, well, yeah, yes and no. This is the repository. I guess you can see it there. It's my GitHub, and it's called Sax-Coin, and it has a README that wait, this is outdated. That's not to do anymore. There we go. So it gives you the Docker commands, and it also tells you how to build the node yourself if you want to. So this repo is all specific to the network that we built today, which is really good and is a fun exercise, no question about it. But the other place to read a lot is on substrate.io. We have several ways to learn. One is the knowledge base. So, that's here. It has a lot of articles. We also have like some tutorials. So there's this create your first substrate chain one. This is one that doesn't even require coding. It just has you download a template project and launch it. So that'll be similar to what we did today. And this one teaches you how to like write your first palette. So if you want to build a custom chain with your own custom logic, it teaches you how to write the Rust code and how to build a user interface for your chain. Yeah.
Okay.
So you can learn a lot about Substrate and how to make your own chains and everything from this website, substrate.io. Yeah.
Okay.
Good, thank you. Good questions.
But Yoshi, I also have to ask the GitHub repo. You maybe can send me the link or place it somewhere, like on the Twitter post or anywhere, because I want to put it in our Slack for the community to also get to the repo.
Absolutely, yeah. This Zoom doesn't have the chat, I think, so I'll send it. I'll email it right afterwards, and then you can post, or on Twitter. Yeah, that's a good idea. Yeah, awesome. Yeah,
so
very good.
From the chat, so far we have no additional questions. Let me fast go in Slack. I hope my internet connection will not be disturbed. And Ralf, do you have any other questions?
No.
Okay, then I just open Slack to check if we get some other more anonymous messages or questions. Yeah, and I maybe also take the time and thank you, Joshi. I would say it was really nice to have such an expert here, even with the long experience. So I think the hands-on, at least for us in the Zoom, was really, really nice. And to be honest, it was kind of the first trial. So we never had this kind of hands-on mentality before in the online meetings. We usually have it in local meetups. If the community of us is deciding the format was okay, maybe we will continue this and do another session about parity. So it was.
I mean, I'm happy to come back anytime, or I could recommend other people in the company who have sort of like different expertise than I do. But I have to say again, it was my privilege to be here. So yeah, thank you guys very much for hosting me.
Yeah, thank you also from my side. It was a pleasure for us that you have time for us, and maybe I think we will discuss this so that we make a deeper hands-on. Maybe we will discuss it, and I will watching the Substrate progress and will try out something.
Cool. Yeah, sounds awesome.
So I think there are no additional questions in the chat.
There is not. No, there is none. No.
No.
Okay. Yeah. Okay, then let's wrap it up. Ralf, I would say we don't have to extend it as longer as it's needed. Maybe I have at least one last question for Yoshi. Yoshi, on which conferences or what events maybe in end of this year you will be, or what you can recommend us, especially in Germany, to attend?
Yeah. So I don't know of a lot of stuff that's scheduled for sure, but the recurring events that I always like to go to, especially in Berlin, which I think that's not so far from you guys, right? Or a couple hours
No, it's
maybe.
not far. It's 2.5 hours
Okay,
by
yeah,
train.
cool. Nice, yeah. So the Web3 Foundation hosts the Web3 Summit. I know it's typically been in August, which I think probably won't. It'll probably be delayed this year. I don't really know, but watch for the Web3 Summit, and so you'll learn all about Substrate, Polkadot, Kusama there. And if you're particularly interested in Substrate or thinking of building your own blockchain, then we occasionally have these Sub-Zero conferences. That's what we call them. And we actually just had one online, like maybe 2 weeks ago, I think. I can send you a link there too. I gave a more of a philosophical talk at that presentation that I'd like to share. And I don't know how much anybody likes to travel, but I'm always a huge fan of San Francisco Blockchain Week, and I go every year there. So if you come over to North America, that's a good one in the fall, October usually.
Okay.
Yeah.
Good. Yeah, then I think we close usually the meetups with some local regional projects. I think now we have the Saxcoin, so we can also use this more. And
Yeah.
Ralf, do you have any other events, maybe also from the Mittweida region also?
No, it's not yet planned, and we see us. I think from the next event will be also an online event. I think so. We have Corona always, and on the 4th of June, it's also the first Wednesday in June. We will start also with Seeker B, blockchain from Nervous. This is a new blockchain. They had an ICO last September, and yeah, maybe it can be also possible that I find or get an invitation from a Polish blockchain application in the insurance Rexes.io. In the insurance area, maybe it's a practical one, but we should discuss it in June. So I think this will be the next event. And yeah, let's do it. And I hope to all stay healthy. And Yoshi, also so much thanks for your time today.
Yeah.
Thanks a lot, guys. Pleasure to meet you. I hope I get to meet you guys in person soon.
Oh, Josh, you maybe don't want to. Maybe we're lucky that we have the remote pleasure first. But yeah, I think it was really nice to have such deep blockchain exchange of knowledge. And also from my side, thanks from the community. The video will be online, can be downloaded, so we will not make it private or take it offline as long as YouTube is not blocking my account. It will be there forever, and I hope we can look forward to more exciting news and updates in our blockchain ecosystem. And so thanks everyone, and I would say bye bye then.
Okay, bye bye. See you next time.
Bye bye.